Okay, this is lesson 1, arithmetic sequences. So what it is, a sequence is a list of ordered pairs, like terms that go on and on and on, consecutive, one after another. What you have, the main thing here is because it's arithmetic, you have a common difference. And difference just means subtract, right? So you subtract one term from the term that follows it. So here's the interesting formula. This is the general formula here, we call it. So t to the n equals t to the 1 plus n minus 1d. And here's everything. T to the n is just the nth term. So for instance, if I said the 10th term, you would have t with a little 10 down here, right? T1 is just the first term, whatever you start with. N is the number of terms you're looking for. So if it's the 15th term, N would be 15, and D is just the common difference. So this formula you don't have to memorize, you're given it, and you just have to know how to use it. Okay, so let's look at the first example. So what we have here is, it's linear, right? Anytime we have a arithmetic sequence, we have a linear, so it forms a line. We have a slope and we have an intercept. So Johnny's a keen student. During each school year, he spends 1.5 minutes more than the previous day on his homework. So he starts off and then 1.5 the next day and 1.5 the next day, more and more and more. On the 73rd school day, he did 152 minutes of homework. So what we do is we want to figure out a couple of things. How much homework did Johnny have on the first day of school? So here's the formula. T to the n equals t to the 1 plus n minus 1d. Let's see what we got. Okay, D. We see right away D, the common difference is 1.5. So we're going to replace that D with 1.5. On the 73rd day, that is the n value, right? That's n. Now, here's the one that everybody's going to get tricky with. On the 73rd day, he did 152 minutes. So we don't put t to the 73 here. We replace it with the actual number 152. So this t to the n is like t to the 73, and we know that that is 152. So we plug in 152, and basically this is just algebra. And you work through and do the algebra, and you find out on the first day, he did 44 minutes of work. Okay. Second part of the question, if the pattern continues, how much will he do on the last night of the school year? So day 180. Okay, so 180. So we know what T1 is, it's 44. We know that we're looking for 180, so that's N. And we know the D is still 1.5. Now here, we replace the T with 180 because that's what we're looking for. That's our unknown variable, right? So then we do the math, right? You do your subtraction first, then your multiplication, then your division, then your addition, and you find out on the 180th day, he does 312 and a half minutes of homework. Now that's good because that's what I expect in this course, right? That's how much math you should be doing. I'm just joking, by the way. Okay, example number 2. Here's the first term of the arithmetic sequence is 12. The nth term is 309. The common difference is 3. What's the value of n? And again, I can ask you for any of these 4 in here. So a couple things. T1 is 12. It tells us that. Tn is 309. We don't know what n is. We don't know what the place is, but we know that that value is equal to 309. D is 3, and we're looking for n. So then we do the math. Here you're going to have to distribute the 3, right? And again, we replace t to the n with 309. We don't know what that term is or what position that term is, but we know what the term is. And we distribute the 3, do all your algebra, work through, and you find out there's 100 terms. So t to the 100, right? So t to the 100, replace that, would be 309. That's how it works. Okay. Example 3. We got is a roller coaster in a fair, has a 15-person lineup when it opens at noon. As the fair gets busier, the number of people waiting in line increases by 6 people per hour. And the fair closes at 11. Okay, so show the number of people standing in line from 4 to 5 and 6. So you got to be careful with this one. So think about this for a sec. 4 o'clock is actually t to the 5. And you're thinking, well, no, that can't be right because that should be t to the 4. But no, it opens at noon. So look, we got 12 as the first one, 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock. And if you count the number of terms, there's 5 there. So don't make that mistake. At 4 o'clock is t to the 5. T1 is 15 because that's how many people are in line right at the start, and D is 6 because it increases by that. So you can see here we plug in the formula. T5 equals 15 plus 5 minus 1 times 6. So at 4 o'clock, there's 39. Now, you could do this formula again and again and again, but we know it just increases by 6. So you could just add 6 for 5 o'clock and add 6 for 6 o'clock. Okay. How many people would be in line 1 hour before the fair closes? So the fair closes at 11. 1 hour before would be 10 o'clock, but you got to be careful. That's not the 10th term. That's the 11th term since we start at noon. So we're specifically looking in this case, hey, there it is there, the 11th term. Plug it all in, right? T1's 15, N is 11, 6 is still the difference, and we find out there's 75 people in line. And they use stuff like this in actual parks and stuff because they have to maintain the proper amount of people in the park. Okay, example 4. 3 consecutive terms of an arithmetic sequence. Now here's a couple things. So consecutive means one after another, right? Are given by x, 3x, and 4x plus 5. Those are the terms. Now they don't have to be numbers, they can be variables and numbers. So first term is x, second term is 3x, fourth term is 4x plus 5. Determine the value of x. Well, the cool thing about arithmetic sequences, what makes it an arithmetic sequence is it has common differences. And to find the differences, we take the second one minus the first. So, right, 3x minus x equals the common difference. Now, if that's also true, then the third term, 4x minus 5, subtract 3x, you can see we did it right here, also equals d. They have common differences. Now, here's the cool thing. This part here equals d. This part here equals d. Therefore, based on that, those two things have to equal each other, right? So 3x minus x equals 4x plus 5 minus 3x. And then you just do the algebra, right? And you find out that the x value is 5. So then what we can do is we can actually find the terms, right? The first term is x at 5. The next one is 3 times 5. And the third one is 4x, 4 times 5 and then plus 5 again, so 25, right? So you can use that. Now, the key thing with arithmetic sequences, they have to have a common difference, right? And the other main part of it is make sure you understand T1 is easy, it's the first term, n is the number of terms, d is the common difference. This is the one, this t to the n is the nth term. That's the one that's going to confuse a lot of people. So remember, they might say that the 10th term is 50, right? So t to the 10 can be replaced with 50, right? So you just have to be careful of that nth term. Okay, so that is lesson number 1.